It's Colorado.
Oh, right.
It is Colorado. There you go, Colorado.
So anyway, if we have the equation y equals, are you ready? Y equals negative square root of x plus 1 minus 5. Yesterday, we would have been trading the x and the y, and we would have been solving for y. We would have done it all by hand. But today, we're not going to do it by hand. We're going to do it graphically. Okay? So I'm going to go ahead and draw the graph. If you have graph paper, feel free to get it out. If you don't, sorry, because I don't have any for you. So when I graph this on my calculator, what point am I looking for? To graph it on my calculator so I know exactly where to look on the table to make sure I get all my values in. Yeah, I'm looking at -1, -5 because I can see that that is the locator point for this graph. So I'm going to say locator point is -1, -5. I can already graph that. So left 1 down 5 is right here. And then I'm going to go ahead and graph that equation on my calculator. And then I'm going to go ahead and hit second graph. And when I look at the table, I'm looking for that value -1, -5. Now, I can't graph anything to the left of it because it says error, but I can go ahead and graph the stuff to the right. So I have the point, oh dang, 0, I said oh dang because I need more graph. I've got the point 0, -6. So here's 0, -6. Then I have 3, -7. 1, 2, 3, -7. And so my graph looks like this. You can go ahead and hit graph if you want to verify that. There we go. Okay, so we're going to write down a few things about this graph before we find the inverse. So one thing I want us to write down is what the domain of this graph is. What is the domain? How far left does it go? How far right does it go? -1 is the furthest to the left that it goes, right? Because that's not an arrow, it stops suddenly. And positive infinity is how far right it goes. Okay, what about the range? How far down does it go? How far up does it go? Does it go up forever? So -5 is the very highest it goes. What's the very lowest it goes? Negative infinity. Which one of those do we write first? We go down to up. Yeah, we do smallest number to biggest number, so we go down to up. So down would be negative infinity. The highest up that it goes is -5, and then we put a bracket around -5 because that's an actual point that we have. Okay. Do we have any intercepts? Yes, there's not an x-intercept, right? But there is a y-intercept. What's the y-intercept? 0, 0, -6. Okay, so let's go ahead and we'll go back to our calculators, and now what we're going to do is we're going to graph the inverse. All right, I'm going to switch to yellow because that's my favorite on here. All right, so I've got second graph, and then instead of graphing the point -1, -5, what am I going to do instead? -5, -1. So I'm going to go left 5, down 1. I do have to extend my graph again. Okay, and then instead of graphing 0, -6, what am I going to graph instead? -6, 0. And then instead of graphing 3, -7, what am I going to graph? -7, 3. Okay, so my graph looks like this. And if you guys can see, it's been reflected over this line. You guys see that? If I folded my paper in half right here, it went from this side to this. And just in case you missed it in the video, what is this line that it was reflected over? Anyone catch that in the video? It's the line y equals x, which makes sense because you're trading your x and your y. So it's been reflected over the line y equals x because those values are trading. Okay? So inverses reflect over the line y equals x, which is why you wrote that on your notes last night. Okay, so if we look at this graph right here, can anyone tell what the domain is? How far left does it go? How far right does it go? So it's to the left. It is an up arrow, but we're thinking left to right, so we're thinking left arrow. So what do I see when I say a left arrow? What do I mean by that? What number is a left arrow? -infinity, so we're going to say it goes -infinity to the left. And then how far to the right does it go? -5. So what do you guys notice? Yeah, something that described the y's before describes the x's now. Does that make sense? So when we're talking inverses, our x's and our y's trade. So something that described the y's before now describes our x's. Okay, let's go ahead and do the range. So we're looking at how far down the graph goes to how far up it goes. What's the very furthest down? -1. Okay, and then how far up does it go? +infinity. Okay, so what do you notice there? Comparing the range to the original domain. So this domain described the x's. So in the inverse, it describes the y's. You guys see that? Okay. And then the y-intercept was 0, -6. And so what is the x-intercept now? -6, 0. So when we talk about inverses and the original function, we notice that anything that has to do with x and y is going to trade. Make sense? Anything that has to do with x and y is going to trade. Thank you. Okay, let's go ahead and look at another one. Y equals... Is there a function you guys are kind of scared of? Is there anything we don't like working with? No, we don't really care? We're good? Okay. We'll do 2 times the absolute value of x minus 1 plus 3. 2 times the absolute value of x minus 1 plus 3. I want this to fit on the graph better, so go ahead and scribble out that plus 3 and write minus 3 instead. It's going to fit better if we do that. Okay, so if I look at that and I'm graphing my original problem, what is the vertex for my original problem? 1, -3. Ooh, you know what we should do? Let's go back up here. The locator point for the original function was -1, -5. Locator point for the inverse. -5, -1. And that fits what we know about inverses, right? We just trade all the x's and y's. So it would make sense that the locator point did exactly the same thing. Traded the x and y's. Okay, so now let's go back down here again. Our vertex is 1, -3, so we already know that we can graph that. So I can go right 1, down 3, 1, 2, 3. And then I'm going to go ahead and graph this on my calculator. Anyone remember how we get an absolute value sign in there? Hit the math button, Go over to number, and it's the first one. Okay, so we've got x minus 1, and then on the end we've got a minus 3. And then I'm looking at the graph, and I can see I've got the point 1, negative 3, and then I have to do some of the other points around it. So I need to do 0, negative 1, and 2, negative 1. So 0, negative 1, and 2, negative 1. And then I need to do negative 1, positive 1, and 3, positive 1. I could even keep going. I've got negative 2, 3, and 4, 3. If you want to just do that, that's fine. Oh, my graph isn't perfect, but okay. So what is the domain for this graph? How far left does it go? How far right does it go? Negative infinity, positive infinity. What's the range? How far up does it go? How far down does it go? Okay, so negative 3 at the bottom, positive infinity at the top. What do we put around those? Okay. Can you guys tell what the y-intercept is? 0, negative 1. How about the x-intercepts? Those are decimals, right? Let's go ahead and find them. So what do I need to do to find my x-intercepts? Yeah, so I'm going to do second trace, option number 2. So I think the x-intercept is right in there, so I need to go over to the left side of it. Press enter. Right side, press enter. I don't hear much typing. You guys letting me do it? Cheaters. All right, negative 0.50. Yeah, smart. All right, and then we've got the other one, which is 2.50. Okay, so before we even graph the inverse, I want you guys to tell me some information about it. So what information could you give me about the inverse? What's the vertex of the inverse going to be? Okay. What's the domain of the inverse going to be? Are you sure? Because that would mean the x's are staying x's. So the y's are going to become the x's. So we're going to say the domain would be negative 3 to infinity. What would the range be? Negative infinity to infinity. So we're saying the x's become the y's, and the y's become the x's. How many x-intercepts are there going to be? 1. Okay, what's the x-intercept going to be? 0, negative 1? Negative 1, 0. So we still have to trade the points, right? This is still an x-coordinate and a y-coordinate, so we do have to trade them. So something that was a y-intercept before is going to become an x-intercept now. How many y-intercepts are we going to have? 2. What are they going to be? 0, negative 0.5, and 0, 2.5. Okay. So I can find a lot of information about the inverse without actually doing the inverse, right? And so what's the big takeaway? When I say the word inverse, what should you be thinking in your head? What's the primary thing you have to do? Not just opposite, but what do you have to do with your x's and y's? Switch them. And you don't just switch them in the equation, you switch them about literally everything. You switch them with your domain and range, you switch them with your individual points, you switch them with your graphs. So when I say inverse in your head, if you can associate that with switching x and y, you can figure out your way through a lot of different problems. Does that make sense? Okay, so let's go ahead and graph that vertex. We've got left 3, up 1, and then I'm going to go ahead and look at my table again. So we have the middle was that 1, -3, and then let's go ahead and do the opposite of all the points. So we have 0, -1. What am I going to graph instead? -1, 0. So I've got left 1, up or down, nothing. I've got 2, -1. -1, 2, so -1, 1, 2, okay. I've got the point -1, 1, 1, -1. I've got the point 2, -1, -1. Oh, we already did that one. I've got the point 3, 1, 1, 3. Okay, and we have enough now to make that V-shaped graph. I don't have to keep going really. And then can you guys see, if we look at this, it has still been reflected over this line. Do you guys see that? So this part reflected here, this part reflected over here, this little corner reflected over here to that little corner. So we can still see that reflection. Okay, do you guys remember how to tell if something is a function or not? We use our pencil. You guys remember? Take your pencil, you trace it. What's that called? Starts with a V. 3 words. Vertical line test. So if I just look at the green, does the green pass the vertical line test? Yes. So that means if I look at the green one, this is a function. It passed the vertical line test. Okay, that is a function. If I look at the blue, does the blue pass the vertical line test? Not even close, because it's touching 2 different parts. It's touching 2 different parts. It's touching 2 different parts. So when we did this one, we found that our inverse was not a function. So a lot of times people are very interested to know if you find the inverse of something, if it would be a function or not. And this one is not a function. And one of the ways you can tell is you have an input. If I plug in an x value of -1, I get 2 different outputs. And that means it's not a function because every time I plug something in, I should get the same thing out. It's like a vending machine. If you hit the Mountain Dew button, you want a Mountain Dew. You don't want a Mountain Dew or a Pepsi. You want a Mountain Dew because you hit the Mountain Dew button. Does that make sense? So a function is like I hit the button, I get exactly what I expect. Something that's not a function says I can hit the button and I got 2 different choices, but they didn't tell me I had 2 different choices. I just get 2 different things. Does that make sense? So we're going to say this is not a function. So if we look back here at these ones, is the green a function? Yes. Is the blue a function? Did it hit 2 different points at the same time? They're both functions here, okay? So for this one, we've got a function, we've got a function. Okay, how are you guys feeling about that now that we've looked at it a little bit more in depth? Pretty good? Okay, one last thing. What if I gave you, they call this a relation. It's not a function because it's not an equation, but they call this a relation. Yep. Okay, if I wanted to find the inverse, what would I write? -3/6 pi -0.5 7 Charlie. All right, so these are pretty easy to deal with because you just have to trade the x and y. Students always think I'm tricking them when I do problems like this because it can't be that easy, but it is. It is that easy. You just trade the x and the y. All right. Okay, I'm going to go ahead and hand out the assignment. Yes. They tell you that if you plug in 2, you get 5. That's what that notation means. And if you plug in 4, you get 5. So what would the points be for the inverse graph? Plug in 5, you get 2. If you plug in 5, you get 4. Now, the special way that we write this with inverse notation is we say F inverse, right? Because that's the inverse graph. And then what did we plug in? So F inverse of 5 equals 2. F inverse of 5 equals 4. Now, I plugged in the same number, but I got 2 different answers. So what do I say? Is it a function or no? Nope. The inverse is not a function because I plugged 2 different numbers in, or the same number, and I got 2 different answers. Okay, if I want to graph the inverse of a function and all they gave me was the picture, what do you think I should do? You can find the locator point. Is 1 point enough to draw the inverse? No, so we're gonna have to pick some more points, okay? So maybe, it's easier to pick where it crosses in a corner than it is to like pick where it crossed in the middle somewhere. So this one, I know it's gonna be a V graph, so it doesn't really matter where I pick the points. So I'm just picking a couple points. So the locator point was left 3, up 5. So I know that for my inverse, that's gonna be 5, negative 3. And then I had left 6, down 1. And then I had 0, negative 1. Yes. So I took those points, I reversed them all, and now I can go ahead and graph it. And then does that fit about what we know about how it's reflected? It's reflected over this line. Does that fit? Does it look reflected over that line? Yeah. This corner reflected over to that corner, this straight part reflected over to that straight part, this straight part reflected over to this straight part. Kind of fits. Okay. Can anyone see some points that we should use on number 4? Can you guys tell where the locator point is? Okay. And then from there, we're looking for corners. So this kind of looks like a corner. Yeah. Oh, yeah. Sorry. I turned it on because I thought we were getting started. But then I'm hoping. Yeah. So we've got the point 2, 4. We've got the point 1, negative 1. We've got the point negative 1, negative 3. We've got the point negative 3, negative 5. And this one is kind of hard to draw, so what I'm going to do is I'm going to put that little dotted line in there. Because then I think that might help me draw my curve a little bit. So I'm going to go right 4, up 2, left one, up one. Can you guys see how well they've been reflected over? Yes, Miss Rice? Marvelous. Left one, or left 3, down 1. Left 5, down 3. So I can see that this needs to make that curve right here. So I can make it make that curve. And then I can see right here it needs to curve towards the dotted line, so I can curve towards the dotted line like that. And then it needs to go away. So see how the dotted line kind of helped me draw it? I think it would have been a little bit harder if I just had the points, but the dotted line made it a little bit more simple. So if we look at this one, the line that you drew in pencil or pen, does it pass the vertical line test? The line that you drew in pencil or pen, does it pass the vertical line test? For number 5 or number 3? Number 3 definitely doesn't, right? Yeah, it touches. So for me, mine's a little bit pink. It touches 2 points at the same time for sure. So is the inverse a function? No, definitely not. What about this one over here? Yeah, definitely a function. Yes. Okay. All right, go ahead and work on the other ones. I will come around to help. We'll get some music going.